the dorsal ramus is what's going to innervate skeletal muscle, okay? And the ventral ramus is going to go to the body wall and to the limbs, somatic, or to the, things like that, to the smooth muscles, because the ventral ramus is what's going to link up to the rami communicantes, and the rami communicantes is going to do a visceral response. It's going to be smooth muscle, it's glands, organs, okay? It's more ventral. It's the one that's more ventral, okay? So the one that links up to that rami communicantes is the one that's most ventral. Yes. So if you synapse here, you're going to link up to the ventral ramus, got it? Ventral ramus, to the rami communicantes, to the sympathetic chain ganglia.
And that's all autonomic.
That's all autonomic, because that's got to now take the path. Remember we were learning about those pre and post ganglionic fibers? Now we got to go do something to the organs, right? That's where it's all coming from. Does that kind of link it together for you?
I'm just confused on like how many synapses there are.
2.
For the somatic.
Typically 2.
For the somatic.
Hmm?
We're doing somatic.
Yeah. Well, for this one, we have our first synapse, okay, in the posterior great horn.
That's
Okay.
like when you receive information.
Yes, we're receiving information.
Okay.
Exactly. Okay.
And it hits the
Now it takes an inner neuron. It doesn't synapse with the inner neuron. The inner neuron is kind of just in between. It's like holding hands. Okay.
Transferring communication.
Yeah. So you have the afferent synapse. Boom. Holding hands with the inner neuron coming down. Now we have the efferent synapse. Boom. 2 synapses.
And then it just like goes to the organ.
Then it goes to organ. But sometimes it gets a little bit more technical because you can remember it's just going to the next effector. So what can an effector be? Well, it can be smooth muscle, it can be a gland, it can be an organ, or guess what? It can be another neuron. So you can have like a link of these things getting to where it needs to go. Does that make sense? So, but that's more technical. Just know most of these are going to require about 2 synapses, okay? Whereas the only one that doesn't is going to be that knee-jerk reaction. The knee-jerk reaction it's a 1 synapse. It doesn't have the inner neuron. It doesn't have the control center. It's bypassing the brain.
Because it's a reflex.
Yeah, because it's the reflex.
What is it, the monoreception? Because we just went over the autonomic, so we're trying to like...
Yes. The autonomic's more complicated. So the autonomic, you're going to get one. You're going to get one of these 2, right? Then if its synapse is here, this is what's telling you it's going to be autonomic. Because if your response is visceral, then you're going to the autonomic system. If you're efferent, if the efferent is visceral, you are going to the autonomic system. Does that make sense? Because it's out of your control.
But if it's somatic.
This is just telling you what the information coming in is. Is it a motor information, or is it autonomic or visceral information? This is the receiving information that's coming in. It can be either or. So I'm not sure, but there might be an example of something that's a motor information coming in, but yet it's going to require a visceral response. I'm not sure on that, but I'm telling you this with 100% certainty. If it's in the visceral, if your efferent synapse is in the visceral, you're going autonomic, which means you're going to go the ventral ramus to the ramus communicantes to the sympathetic chain ganglia, because now you got to go innervate the next effector, whether it's the smooth muscle, glands, organs. Okay?
So lateral horn goes automatic.
Lateral horn goes autonomic. Exactly. Presto. 100%. Okay? If you want it, this is how I wrote it. So I have them separated as the dorsal and the ventral. So the dorsal ramus innervates skeletal muscle. The ventral ramus is like the body wall, limbs, organs, things like that. From T1 to L2, you have the white ramus and the gray ramus, right? The rami communicantes together they are called the rami communicantes, right? If you travel via the rami communicantes, you're innervating smooth muscle, glands, and organs. It's the one that's most ventral in the models and pictures. The rami communicantes will link up to the sympathetic chain ganglia, okay? In which that's going to do the sympathetic nerve, right? So you're going to have a visceral motor from lateral great horn. It's going to travel to the rami communicantes to either the next neuron, to either the next gland, smooth muscle, organ. We call these things effectors. if you can do this, if you can kind of understand what's happening here, you're going to be fine for the multiple choice. Because on the multiple choice, you're going to get something like this. She's going to ask you, what is synapsing here? This is going to be blank, right? And it'll be like blank, okay? You'll have the whole thing to look at. You know, you'll have this portion here, you'll have this here, and then the start of the next one, right? Okay, you'll have like something like this, right? You'll need to know, okay, this is the spinal canal. This bridge has a name, I forgot it, it's in the record something. Huh? Yeah, the Great Commissioner, right? The Great Commissioner? Yeah, thank you. So you have that, right? And then you're going to have the horns, right? So you need to know what each section is, because on your multiple choice, she might ask you, what's this? What's this? Which one's this? Which one's this? Which one's this? Which one's this? And then she'll ask you, okay, you need to identify, is this, are you looking at it this? Because you need to know, okay, is this the anterior or posterior white column? Okay, and the key to doing that is just identify the horns. The horns tell you right away, that's posterior. The ones that are more rounded, anterior. That's it. If you can do that, you're going to get a lot of these multiple choice right. Okay? You might have a word problem where you can do one like this, like a pathway, like I just told you, like if your hair gets plucked, if a bee sting, if she might have one where it's visceral, where you know something with your blood pressure is wrong, something's like really high or something, and you need to. I don't think she'll go that technical. That's more physio, but if you needed to, you could do it because you just need to know this is your map. This is the map. Motor, visceral, sensory in the posterior gray horn. The lateral gray horn will be visceral, autonomic. It will. That's telling you right away. It's going to link up with the rami communicantes to the sympathetic chain ganglia to innervate the next effector, whether it's a smooth muscle, a gland, an organ, or another neuron. Okay. If it's in the anterior, if it's synapses in the anterior gray horn, you know, okay, this is going to be a somatic response. So we're going to just take that dorsal ramus, right? We're going to take the dorsal ramus. We're going to bypass the rami communicantes, and we're just going to go innervate the next skeletal muscle. That's it. We're not going to take those pre and post ganglionic fibers, right? We're not traveling that route. That's all it is.
Did we go over the 4 pathways of the sympathetic nervous system?
4 pathways, like what? Explain to me.
There's the spinal nerve pathway, the postganglion sympathetic pathway, the adrenal medulla, and then this spinatic. We already did the spinatic with Lonnie, but I was just curious about the adrenal medulla pathway, the spinal nerve pathway, and the postganglion sympathetic. Yeah.
Preganglionic. Okay, so preganglionic will always come from the lateral gray horn. I know that. And then they're going to enter the ventral root, right? You just need to know for that one, really, the postganglionic is going to be, if you're talking about the adrenal, it's going to be in the postganglionic. Okay, you need to know postganglionic is going to be norepinephrine, and that's the one that's adrenergic. Okay, adrenergic gets a little bit more complex. You're going to have beta receptors and alpha receptors. I don't know if she's going to go into that much detail for you guys, but beta would be epinephrine only, whereas alpha will be both of them, norepinephrine and epinephrine.
Did she talk about that?
She might not have even given you that much detail. I wouldn't worry too much about those things. Like I said, for your multiple choice, what you really need to understand is this chart, which we're going to do again. Because this chart
Yes, let's do your chart.
is the easiest way to do it. Because she gives you a lot of stuff that is, it's like overwhelming. It's too much, to be honest. Because you're looking at this like a new language for the first time. So you need to understand, okay, afferent, for the autonomic nervous system, afferent is from, like, it's something from, so if we're talking about the autonomic, we already know it's visceral, right? So if it's afferent from the autonomic, it's coming from your internal organs. Everybody agree? Okay, efferent is what I'm telling you. It's going to be smooth muscle, heart muscle, glands, right? Okay, this is where we have to understand you have this dual innervation, right? It depends what system we're in. You're going to have sympathetic and parasympathetic. Okay, and they're going to determine, each one's going to have slightly different path. Okay, so the sympathetic, the way I like to do this, so we already went over this. We have the PNS, right? Peripheral nervous system, right? Okay, basically this is breaking down into afferent and efferent. Okay, afferent, efferent, info. Okay, the efferent is now going to break down into three. Breaks down into three. Because we have three types of responses, right? Somatic, visceral, or sorry, sympathetic,
Parasympathetic.
and parasympathetic. Okay, this one, pretty straightforward, skeletal muscle. Because this one went where? This one, we already told you, was the anterior great horn. Anterior great horn. Okay? Sympathetic and parasympathetic are going to get further divided. Can I erase this? Okay.
So from that efferent, the somatic is the anterior horn?
Yes.
Horn, and then-
Because they're all efferent, right? They're all exiting. They're all, it's now what are we going to do about it? These are the actions.
And the sympathetic and parasympathetic are coming from the autonomic, which is the lateral horn?
Yes. Yes. So here you would have the autonomic nervous system, right? Right? Okay? Autonomic nervous system.
For afferent, is it always sensory, you said?
Afferent is sensory, always. It can be sensory visceral, or it could be sensory motor, or sensory somatic, or sensory autonomic. So autonomic visceral, kind of the same thing. Somatic motor, kind of the same thing. Okay? So both of these, we start here. This is the info coming in. So this is info. This would be info coming in. Info coming in. This is info coming out. To action, right? Okay? Three pathways. You're going to have the somatic, the sympathetic, and the parasympathetic. Okay? The sympathetic, the somatic, like I said, it's pretty simple. It's just going to go through that, like I said, it goes, it's going to take the dorsal ramus. It's not going to link up with the rami communicantes, and it's not going to go to the sympathetic chain ganglia. Okay? That's somatic only, because it's just going to go innervate the next skeletal muscle. Okay? These two are different, because these two are now visceral responses.
I'm sorry, what is the skeletal muscles in the front part of the body?
Doesn't matter. It's still gonna, it's because it goes down. So here you have like all the nerves, right? And you have your spinal column, okay?
Is it still the dorsal?
So it still comes out. Remember, it's still got to come out on either side. It comes out on the ventral rootlets, right? And then I'm saying instead of linking up to the rami communicantes, it's going to go follow its own pathway to innervate the skeletal muscle.
But it could come out through the ventral ramus if it wanted to, right? Because you're saying dorsal ramus.
A sympathetic trunk ganglion is the same thing as a sympathetic chain ganglia.
That's not it.
No, when you see the sympathetic trunk ganglion, it's the same thing. It's the sympathetic chain ganglion. It's what's going all the way down, right? The gray ramus and the white ramus is the ventral and the dorsal. Okay, that's what this looks like to me. Okay, so what I'm telling you is the it's going to it looks like the white ramus is the one that's let's see. Root. Somatic. So let's call it somatic. This is coming in, yeah. So the ventral ramus carries sensory information from the ventrolateral body surface structures in the body wall into the limbs. The dorsal ramus carries sensory information from the skin and skeletal muscles of the back. The dorsal ramus carries sensory information from the skin and skeletal muscles of the back. So skeletal muscles for the back will take the dorsal ramus, okay? And then the ventral ramus will do sensory information from the ventro, so front portion of your body too. So yeah, you're right, it will take the ventral ramus for that too. Okay, it's just not going to link up to the sympathetic chain ganglia. Because the sympathetic chain ganglia is what's going to go all the way up and down, right?
Can you explain to me that? This was good. What last one?
So the anterior root, right? So we're taking the anterior root, and it's going to send nerve impulses to the skeletal muscle. So the anterior root travels, looks like here, somatic sensory nervous system, went over that. So for the somatic nervous system, you literally just need to know that the somatic is going to leave out the anterior root, ventral root, and it's going to send nerve impulses to skeletal muscle. That's all it has on here. Well, the synapses happen here, yeah? Because you have
So those you use it just those like out, outside.
yeah, this one must have.